So just coming back from talking about the inverter, we can look at the other part of the NAND gate. Okay, and we can look at this diode logic example. And let's ask ourselves, notice first of all, before we ask any questions, that this one is considerably different in that there are now two inputs and only one output. So let's figure out how they're related. We'll create a table much like a truth table, A, B, and V out, and try to reason through the various inputs this way. And we'll label the inputs logically with zeros and ones, and let's figure it out. Okay, all right. So these are regular diodes that should turn on maybe at say 0.7 volts. So if we just consider low inputs, in this case, A is 0 and B is 0, the diodes are not going to be turned on, and as we see, no current should flow, and the output should just be 0. So the output will be low. Okay, but if we turn on one of these, say by applying B, for example, by applying 5 volts here, and what that means is really we're connecting this kind of thing here. Okay, but we can just write an equivalent thing here just by saying it's 5 volts right at the node. We're just labeling the node here, but really that's equivalent notation. So let's say we're turning on B. This means that this diode is going to be conducting. It's going to have a 0.7 voltage drop across it, and in this case V out is going to be, well, reduced by from 5 volts. It's going to be but it's going to be high, right? It's just going to be 0.7 volts below high. Okay, maybe 4.3 volts, but it's still our logic 1, right? And of course the same thing is going to happen if you just turn on diode A. That's going to be high as well. And if you turn them both on, well, both of them are going to be high. Okay, well, actually, I mean, V out is going to be high, right? So what kind of gate is this? This is an OR gate, right? Well, all right, it's not going to let me write over there, so I'm just going to write like this, OR gate. Okay, let's try another example. Okay, so this one is a little bit different. First of all, you might notice that these two diodes are positioned in a different direction, and also the output is connected to VCC through a resistor, okay, as opposed to the ground. But let's analyze it the same way we did before. A, B, V out, okay, and 0, 0, 1, 1, 0, 1, 0, 1. All right, so when A and B are both low, what's going to happen? Okay, when A and B are both low, we're going to turn on the diodes, right? So let's imagine we applied 0 volts here, 0 volts here, right? We're going to turn on the diodes because this is high, it's connected to VCC, and current is actually going to flow this way and this way. This current is going to flow, okay? All right, and also what's going to happen is that we're going to have a voltage drop across the diodes like this, 0.7 volts across each one of them, and so this will force the V out to this voltage exactly, right? 0.7 volts. So that's going to show up, as you see, this is all the same node. Okay. So this is going to show up at the output as 0.7 volts. Is 0.7 volts high or low in our logic system? Okay, well, if you answered that 0.7 volts is low, you're right. So this is going to be low. All right. Now let's say that what we're going to do is we're going to turn on one of the one of the inputs. It's going to be a logic 1, which means you're applying 5 volts here. Well, now at least for this diode, okay, for the upper diode, for this one, we have 5 volts here, 5 volts here, and this diode is just going to be off, right? So the diode in path A is going to be off or open circuit. Okay, but this diode is still conducting, and therefore still at the output voltage we're going to have okay, it's not letting me write there. At the output voltage we're still going to have 0.7. Oh, see, again, not letting me write. 0.7 volts. Okay, I'm just going to leave it like this. Alright, so nothing changes if only one of the diodes is turned on and the other is turned off. So we can write, again, the output is low, it's going to be 0.7 volts. Alright, obviously if we reverse the diodes A and B, the situation is similar, they're just exactly in parallel, and this is going to be low. Alright, what's going to happen if we apply high to both of them? Okay, if we apply high to both of them, this is going to be open circuit, right, because you're not going to have a voltage drop from P to N. This is going to be an open circuit, right, so this is all disconnected here, and no current flows into the diodes, and V out then is going to just be connected to VCC with no voltage drop across this resistor. Okay, so it's just going to be VCC, and of course VCC is the high voltage in our system, so this is going to be high. And you probably realize that already that we've been implementing an AND gate. So this one is an AND gate. Alright, cool. In the next little video we will revisit the whole NAND circuit.